Thank you.
Okay. In a static routing, what you will do, see here, let's say router 1 is connected with one network, here 10.1.1.0/24, and here we have one network 20.1.1.0/24. So manually network administrator will configure 20 network on router number 1 and 10 network on router number 2. But in dynamic routing, we will run a process on router, and router will see a routing information on the basis of that process. Router will share routing information on the basis of that process. See, first of all, router need what information to build routing table? Remote network, correct? Destination network, then remote subnet mask, and next hop address, or you can say exit interface. Exit interface. Router need these three information to build routing table. Now who will tell these information to routers in dynamic routing? Routing protocol, dynamic routing protocol. So in a static routing, network engineer will provide these information like destination network, remote subnet mask, and next hop IP address. But in dynamic routing, router itself give information to neighbor. Like here we have this topology. Let's say this is R1 and this one is R2. For R1, R2 is the next hop. For R1, R2 is the next hop. Who will tell to R1? R2. R2 will tell to R1. Let's say here R1, R2 is connected with one network. This is 10.1.1.1. So R2 will tell to R1 that brother, please take this network, please install this network in your routing table, and whenever you need to forward traffic in this network, you should forward it via me. You will forward it to me. Means router 2 is going to tell to router 1 what is the next hop IP address for this network. Getting my point? So now here we have some drawback about a static routing, like it is complex to implement in large network, no redundancy. We don't have redundancy here. So that's why we come up with dynamic routing protocol. And now how many types of dynamic routing protocol we have? So we have four types of dynamic routing protocol. First one is distance vector routing protocol. An example of distance vector routing protocol is RIP. Then link state routing protocol, example is OSPF. Advanced distance vector routing protocol, example is EIGRP. And path vector routing protocol, example is BGP. So we have four types of dynamic routing protocol. Okay, and if I will talk about the other protocol, we have two routing protocol in link state routing protocol. One is OSPF and another one is ISIS, right? But this one is very advanced routing protocol. Generally we are using in the large network, in the on the internet. We are not using it in enterprises. So that's why here I have not mentioned ISIS protocol. At the end, after completion of syllabus, if anyone want to learn ISIS routing protocol, so I can give you some overview about this protocol also. Fine. So for now, we have four types of dynamic routing protocol. We need to understand each one by one. So for now, we are not going to discuss path vector routing protocol, that is BGP. We will discuss it later. For now, just focus on these three dynamic routing protocol: distance vector, link state, and advanced distance vector. And I must tell you, see, advanced distance vector routing protocol is combination of distance vector and link state. It is combination of distance vector and link state. Advanced distance vector routing protocol have some properties of distance vector routing protocol and some properties of link state routing protocol. So you need to learn only these two: distance vector and link state routing protocol. Fine. So after discussing distance vector routing protocol properties, we will discuss RIP routing protocol, right? Because RIP is a example of distance vector routing protocol. But first we are going to understand the properties of distance vector routing protocol. Means how distance vector routing protocols is going to exchange their routes, how it is going to share their messages, right? These things. So let's begin. Here you can see properties of distance vector routing protocol. Guys, distance in the networking means hops, number of hops, like your router, your layer 3 device, your layer 3 device. Distance means, let's say here I have router 1 is connected with router 2, router 2 is connected with router 3, and router 3 is connected with one network X. So X network is how many hop away from router number 1, or let's say here we have one another network Y. So between X network and Y network, how many hop are there? So 3 hops are there. So router is considered as hops, or layer 3, it can be layer 3 switch, it can be any layer 3 device. Fine. So like from router number 1, if you will see X network is how many hop away? 3 hop away. X network is 3 hop away. So this is nothing but distance, and that means every distance vector routing protocol will calculate their best path on the basis of hop count. Distance vector, this is first property. Distance vector routing protocol calculates their best path on the basis of hop count. Means, let's say I have one topology. Let me give one example here. I have one topology like this. R1 is connected with R2, R2 is connected with R3, R3 is connected with R4, and this R4 is connected with R5, and this R2 is also connected with R5, and here we have one X network, and here we have one network, that is, let's say, Y. So between X network and Y network, how many path is available? Between source and destination, how many path is available?
2.
2 path. But according to distance vector routing protocol, which path is best?
R2.
R2.
Via R2. Because as I told you that distance vector routing protocol calculates their best path on the basis of hop counts. So it is going to count that how many hops are there from this path and how many hops are there from this path. So from this path, 1 hop, 2 hop, 3 hop. From this path, 1 hop, 2 hop, 3 hop, 4 hop. Getting my point? So list number of via upper path, we have list number of hops. So upper path is best path.
So it will also consider that R1 as a hop.
For now, just understand between source and destination.
Okay.
Definitely R1 will decide that which path is best. For R1 there are two choice. R1 have two choice. R1 have two path. Yes or no? Not for Y. Y have two path. R1 have two path. Router 1 is going to check. I have this destination is 1 hop, 2 hop away via upper path via router number 2, and 1, 2, 3 hop away via lower path. So that means upper path is the best path.
It's like from R1 to R2 is 1 hop, and from R2 to R5 is another hop.
From R2 it is 2 hop, na? 2 hop away. 1 hop is R2, another is R5. So destination network is 2 hop away via router number 2, and destination is 3 hop away via router number 3.
Okay.
So best is via router number 2. Guys, here we can say, let's say here we have one 1 Gbps link. This is 1 Gbps link. This is also 1 Gbps link, and this is 10 Gbps link. This is 10 Gbps link. This is 50 Gbps link. So better path is lower path, right? Here we have more bandwidth, but distance vector routing protocol does not have capability to check bandwidth or these things. Distance vector routing protocol will check only hop counts. On the basis of that, always it will check which path is best. Fine. This is the first property of distance vector routing protocol. Second property of distance vector routing protocol is, that means metric in the distance vector routing protocol is hop count. Okay, this is the metric in distance vector routing protocol is, as I told you in last class, yesterday class, that router is going to check third components. After checking AD value, it is going to check metric, right, to check which route path is more reliable. That is metric. So in dynamic routing protocol, each routing protocol will calculate their metric, and distance vector routing protocol will calculate their metric on the basis of hop count. So that's why here we are saying that means metric in the distance vector routing protocol is hop count. And second property is distance means hop count, and vector means direction. So distance vector means direction, and direction in the networking means next hop. What should be the next hop? What will be the next hop? So next hop is nothing but direction. So distance vector routing protocol will always send periodic update to their neighbor after periodic interval. This is second property of distance vector routing protocol. First property is it is going to calculate their best path on the basis of hop count, and second property is it will always send periodic update message. See here I have router 1 and router 2. Guys, let's say here I have configured one distance vector routing protocol, that is RIP, right? Then router 1 need to send this network to router number 2, and router 2 need to share this network to router number 1. So both router will send update message. Router 1 will also send their update message to router 2, and router 2 will also share their update message to router 1. And this update message is periodic in nature. Means after a specific interval of time, router will send one update message. Let's say timer update time is 30 seconds on router 1 and router 2. So after 30 seconds, router 1 will tell to router 2, brother, I have one network, please install it in routing table. Please install it in your routing table. Again after 30 seconds it will send, again after 30 seconds it will send, right? Because this is periodic. Distance vector routing protocol always share periodic update. Okay, so these are disadvantages as well, like distance vector routing protocol utilizing the bandwidth of this link unnecessary, because router 1 need to send this network information to router number 2 only once, right? When router 2 will install this network 192.168.1.0 network in their routing table, then router 2 don't need any update message from router number 1. If change will occur, then definitely update message is required. But until and unless topology is stable, network is stable, update is not required. So distance vector routing protocol always send periodic update. Okay, second property of distance vector routing protocol.
So as router 1 sending update to router 2, will that router 2 respond or acknowledge that request? That yes, we have added that network into
So
our.
that we are learning now, brother.
Okay.
Okay, second property is it will send periodic update. Distance vector routing protocol will always send periodic update to their neighbor after periodic interval. After that we have some loop avoidance properties, like how routing loop are prevented in distance vector routing protocol. Because let's say here I have this topology. In this topology, router 1 is sending one update message to router 2, update message, and it is possible that router 2 again will send same update message to their neighbor to router number 1. Let's say router number 1, and here I have one another router R3, right? So it's responsibility of R2 to share same update message which router 2 have received from router 1 to their neighbor to router number 3. So it will share the same update message to router 3. And what will happen if router 2 will send same update message to router 1 also? Same update message to router 1 also. This is loop. Yes or no? Router 1 is sending the update message to router 2, and router 2 is forwarding same update message back to router number 1. Done. So how loop will prevented here, guys? In distance vector routing protocol, see, in distance vector routing protocol, whenever, see, this is the topology, R1 have one network, A network. Router 1 is sending one update message to router number 2. In that update message it is sending A network information, and router 2 is also sending same network information, A network information, to router number 1. But it will not happen like this. Router 2 will never send A network information to router number 1 because of a split horizon. Because of this concept, split horizon is a feature of distance vector routing protocol. Split horizon means never send the same update message from the receiving interface. Same update message from the receiving interface. Like router 2 is receiving this update message on this interface, so it will not send this update message from same interface. Do not send same update message from the receiving interface. And guys, tell me when router 1 will send a network information to router 2. Router 2 will receive a network information, and what will be the next hop IP address? IP address of this interface is, let's say, A1. IP address of this interface is A2. So on router number 2, what will be the next hop IP address for A network?
A2.
A1 or A2? A2 1 na?
A1.
A1.
This IP address will be the next hop IP address for A network on router number 2. So when router 1 will send this update message, in that update message there will be source IP, destination IP. So source IP will be A1. And when router 2 will receive the update message, it will check up in the update message there is information of A network. Okay, that is fine. Then router 2 will check, okay, I am receiving this update message from which source? So source is A1. That means whenever I want to reach in this network, next hop will be A1. Right? I am receiving, let's say someone is giving me some network information, right? 10.1.1.0/24 network. Someone told me this network, right? And in the update message, source is 192.168.1.1. That means whenever I want to send traffic in 10 network, 10.1.1.0 network, next hop will be always the source, which was in the update message. Right?
Yeah.
Okay. So a split horizon is a feature of distance vector routing protocol, which is used to prevent routing loop. And by default, a split horizon is enabled on all interfaces. Then we have one more property of distance vector routing protocol, that is route poisoning. Let's say here.
Sorry for the interruption. Can you please elaborate more for that split horizontal?
A split horizon, no? Okay.
Yeah.
Let's say, brother, I have router 1 here. Router 1 is connected with one another router R2. Router 2. Okay. And router 1 is connected with one network. Here we have one network, X network. Okay. So router 1 will share X network information to their neighbor, X network. And router 2 will do what? Router 2 will share same update message to their neighbor. So router 2 have one neighbor, that is R1. So it is responsibility of R2 to share same network information to R1 also. So it will share same network information to R1. But here we have enabled a split horizon. And a split horizon rule is, do not send update message from the receiving, same update message from the receiving interface. So router 2 will not send this X network information from this interface, the update message from this interface. Clear?
Okay, I got it. Okay, thank you.
Okay. Now next property is, let's say, see this topology. In this topology, I have three router R1, R2, R3. R1 is connected with one network, A network. So R1 will give A network information to R2 also, to their both neighbor, to R2 also, to R3 also. Fine. R2 will share that network information to R3 also, and R3 will share that network information to R2 also, right, to their neighbor, because it is not receiving on this interface. First it will send, both router will send update message to their neighbor. Router 3 will share to router number 2, router 2 will share to router number 3. After receiving the update message on this interface, router 2 will stop sending update message from this interface, and router 3 will also stop sending update message from this interface. Now what will happen after some time if this link will goes down? If this link will goes down, then router 2 should send A network information to router number 3, because A network is still reachable via router number 2. Yes or no? A network is still reachable via router number 2. But if you are thinking that router number 2 is not going to send A network information to router number 3 because this is a split horizon. This is breaking the rule of a split horizon. Because earlier router 2 was was receiving same update message on this interface. So guys, this is not like that. See what will happen when this link will goes down. Router 3 will send one update message to their neighbor. Same network, a network information will be there in the update message, but delay will be infinity there. Delay infinity means now this network is not reachable from me, right? So when router 2 will receive update message from router number 3 with delay infinity, router 2 will send same update message to router number 3 from the same interface, from the receiving interface. It have received the update message on this interface, right? In the update message there was a network information, and it is sending same update message from this interface. This is not the breaking of rule, this is not the breaking of a split horizon rule, because in the first update message delay was infinity. So this is called root poisoning. Like here also you can read, R3 will receive the information of a network from two side, but R3 will store via R1, and if R3 will lose the connectivity via R1, then R3 will send update message to R2 and mark metric as infinity. This is not breaking the rule of split horizon, it's working fine, and that is called root poisoning. Root poisoning means, you know, let me explain here again, same thing. Let's say I have a same topology R1 connected with R2 and R3, and here we have one network, a network. When we will configure distance vector routing protocol, router 1 will send update message to router number 2, router 1 will send update message to router number 3. Both router will update their database, their routing table. Both router will install a network in their routing table. After that, router 2 will send same update message to router 3 also, and router 3 will send same update message to router 2 also. But when it will came to know that same network information I am receiving on this interface, both router will stop sending update message. Fine. After some time, if let's say primary link will goes down, let's say link between router 1 and router 2 will goes down, then R3 will send first one update message with metric infinity, with metric infinity. And you know, in the update message, whenever distance vector routing protocol will share what update message, it will include hop count also. Hop count, how many hop are there? Like when router number 3 is receiving update message from both router, like from router number 1 also and from router number 3 also, how router 3 will came to know that I am receiving best update on which interface, on this interface or on this interface? So in this update message hop count will be 1, in this update message hop count will be 2. So router 3 will install via router number 1, best path is via router number 1, right? And whenever this primary link will goes down, what router 3 will do? First router 3 will send one update message with metric. It will mark metric as infinity, means I don't have reachability. It is not sending the update message, it is informing to router number 2 that from me there is no reachability to a network. If you have any path, please send me. Then in the response of this update message, router 2 will share the actual update message which will carry a network information, and then router 3 will install again a network via router number 2. So this is called root poisoning in the distance vector routing protocol. So we have only these properties of distance vector routing protocol. When we will discuss RIP routing protocol, you will see these all properties. Okay,
I have one doubt.
yeah.
So, is this like it is from for the AA network, we are advertising the routes, right?
Correct.
So from R1 to R2 and R1 to R3.
Correct.
Now when R2 is updating R3, it will say that A network is reachable via me, right? It is like that, or
Yes, correct.
so that update and the update R3 gives R2 will be different, right? I'm getting confused there.
No, same update, only hope count will be different. When R2, R1 will send in the update message, hope count will be 0. When router 2 will send it to router number 3, hope count will be 1.
One, okay.
Only these difference will be there, right? Rest thing will be same. The network will be same, right?
Yeah.
Update message is exactly same.
Okay.
Okay.
So the same happens via R3 also.
Yeah, via R3 also. Let's say if this path will goes down, router 2 will send this time update message with metric infinity.
Okay. Okay.
Okay. Anything else, guys? Any other dot?
Yeah, you
Gee,
are saying that
yeah.
it's route poisoning, right? Whether it is a benefit or it's a, I mean, it's a error. It's like a vulnerability.
No, it is benefit. Now, sometimes people are confusing that when primary link will goes down, then because of a split horizon, R2 will not send update message to router number 3. That's why I have discussed route poisoning. It is benefit that whenever primary link will goes down, router can get the backup link. Otherwise, let's say we don't have route poisoning here, and I have same topology R1, R2, R3. If primary link will goes down, link between router 1 and router 3 will goes down, router 3 will never came to know what is the alternate path. Router 3 will never came to know about the alternate path because of a split horizon. Because a split horizon is enabled over here, when router 3 will send update message, router 2 will never send same update message from this interface.
Got it. Thank you.
Yeah.
If suppose that primary link will come up means actually what it will
Again,
happen?
router 1 will send update message, right? When this link will come up, router 2 will send update message, and router 3 will receive update message with lower hop count. It will come to know that, my god, this path is worth, let me remove it. Getting my point?
Okay.
When router 2 is giving update message, in the update message hop count is 1, here hop count will be 0. So router 3 will come to know that now best path is via router number 1. It will flush this path and it will install this path in their routing table.
Okay. Okay.
So Praful, actually, just want to know, like, when R1 sending information to R2, and that information R2 sharing with R3, right? The same
Correct.
information. So R3 will aware that R2 having that path to reach R1, right?
Correct.
So here that R3 is aware that R1 is reachable by R2. So like when the link.
When R2 will receive update message from router number 3 on this
Mhm.
interface, because of a split horizon, it will stop sending update message from here.
Okay.
So router 3 is not receiving any update message from router number 2. It is receiving update message from router number 1 only after every 30 seconds, let's say. After a specific interval that we can change it. We can change the timer. Getting my point, Sanjeev?
Right. No. In the case of that R1 to reach R3, the link when goes down, then the
Correct.
connection R3 should aware, right? R3 having the information to reach R2 and R1 as well.
Once R1 will not receive update message after 30 seconds, it will come to know that something is wrong here.
Yeah.
If let's say I am sending you update after 30 seconds that I am good, and if you will stop receiving the update message from me, you will come to know that Praphul is not good or something is wrong between me and Praphul.
Yes.
Anything else?
The metric 0, that prefix update will be sent to all the routers connected to R3 or only connected to R2.
R3? Sorry, again, please explain the question again.
If the link between R1 and R3 goes down,
Okay.
R3 will send the request for that prefix, no?
Yeah, to
Uh,
R2. And let's say
by
R3 have one more neighbor here, R4. So it will send same request message to R4 also.
whoever having that prefix, they will reply back, right?
Correct.
Okay, thank you.
Anything else, guys? Till here? No? So here also you can read this file what it's saying. Now R1 is giving information of network A to R2 on fast Ethernet 0/0, and R2 will never send this information of network A on fast Ethernet 0/0. This is a split horizon, correct? But if R1 will send update message on fast Ethernet 0/0 and mark metric as infinity, this is called rod poisoning. Again, I have explained same thing here also. An example of distance vector routing protocol is RIP. Now let me discuss some properties of link state routing protocol. First of all, guys, see, in distance vector routing protocol, routers are not going to maintain any table. Both router is going to maintain only routing table that router is already maintaining. It will start maintaining, router 1 will
See,
start
hello.
maintaining. Yeah.
Sorry for the disturbance. See that matrix is infinity means here that matrix means that is hope count only, right? Means
Yes,
hope
correct.
count. It's like a infinite, or
Correct.
how it is?
Correct. Hop count
Unconditional.
is infinite, means this network is not reachable.
Okay.
When we will enable distance vector routing protocol on router number 1 and router number 2, let's say I have enabled RIP routing protocol here on router 1 also and on router number 2, both router will start maintaining RIP routing table for RIP. In their routing table they will install this network, router 2 will install this network, it will install this network also, right? And after that, directly router 1 is going to share the entire routing table to router number 2 in the form of update message. Router 2 will share entire routing table to router number 1 in the form of update message, right? Without exchanging any other message. RIP is a application layer protocol which uses TCP or UDP. UDP. Port number 520. Okay, but if I will talk about this link state routing protocol, so first property of link state routing protocol is it will maintain 3 types of table. If we are running link state routing protocol on router number 1 and router number 2, let's say OSPF. So OSPF is not going to exchange routing information directly. First of all, these two router will become neighbor. First of all, it will check some parameter. If parameter will match, then two router will become neighbor. After becoming neighbor, both router is going to maintain topology table database, right? Both routers are going to exchange database, and after exchanging database, router itself going to calculate best routes, best path, and then it will install in their routing table. So link state routing protocol maintain 3 type of table. Link state routing protocol maintain 3 tables: neighbor table, database, and then finally routing table. First router will discover the neighbor. If router 1 have one neighbor R2, it is going to make one entry in their neighbor table that my neighbor is router number 2, IP address of router 2, router ID of router 2, and router 2 will also make one entry in their neighbor table that my neighbor is router number 1. After that, both router will exchange database with each other. If after becoming neighbor only, let's say there are some criteria of neighborship also, some parameter are there. If parameter will not match, these two router will not become neighbor. Like in distance vector, there is no any criteria like neighborship is required or anything is required. Directly routers are exchanging their routes. But in link state routing protocol, it is going to exchange the database, and on this database router will run one algorithm, and after that it will calculate routing table. Both router will calculate their on routing table. But distance vector routing protocol exchange their routing table directly. Okay, so this is first property of link state routing protocol. In case of distance vector routing protocol information was directly exchanged between router, but in case of link state routing protocol, router will not directly share information. First of all, router will check some parameter, then router will become neighbor. After becoming neighbor, router will exchange database. Database means network information, and after exchanging database, router will build routing table. Router will build their own routing table. And second properties is, here we have some message, some periodic message also, and trigger message also. Like in distance vector routing protocol, we have only periodic message, correct? Periodic message. But here in link state routing protocol, we have some periodic message also, and we have trigger message as well. Trigger message means first time it will share the complete update, and second, after that it is not going to send any update message until and unless change will occur in the topology. If change will occur, then only it will send update message. So trigger means when there is change in topology, router will send trigger update. And metric is depend on link property here. Metric is also not like hop count. Blindly hop count is the metric. Here in distance vector routing protocol, metric depends on link properties. It depends on bandwidth of link. Getting my point? And routing is not done by rumors. Like guys, if I will give you one more example of distance vector routing protocol, let me give one more example here. Let's say, see, I have one network like R1 connected with R2, connected with R3, and connected with R4. And R1 is connected with some network, let's say A, B, and C. What R1 will do? R1 will send update message to R2. It will share A network, B network, and C network to router number 2. Router 2 will share same network information to their neighbor, A network, B network, C network, and router 3 will share same network, A network, B network, and C network to router number 4. What router 4 will think? Router 4 will think A network, B network, and C network. All network is available on router number 3. All are available on router number 3. Router 4 don't know anything about the topology. Router 4 never came to know that actually A network, B network, C network is connected with router number 1. Router 1 have shared it to router 2. Router 2 have shared it to router 3. And finally router 3 have shared to router number to me. Router 4 will always know only their neighbor. Router 4 will think that all network is connected with router number 3. So this is called routing by rumors. Rumors means every router is dependent on their neighbor only. They don't know about the actual originator, who is originating this network information. Getting my point? So distance vector routing protocol is called routing by rumors. All routers are dependent on their neighbor. But if I will talk about link state routing protocol, so here you can see link state routing protocol, routing is not done by rumors. Every router have knowledge of topology. All router will have entire topology. Means router 4 will have knowledge that actual originator is router 1. Router 1 have shared the update message to router 2. Router 2 have shared to router 3, and router 3 have shared to me. But distance vector routing protocol, all router depends on their neighbor. Fine. No limit of hops. If I will talk about distance vector routing protocol, so distance vector routing protocol support only how many hops? 15 hops.
16.
Yeah, 16 hops. So we can connect only 16 router, right? If a network X network is there which is 16 hop away from router number, let's say here I have one router R1, and X network is around, let's say here we have, this is 17th router, this is 16th router, and this is, here we have, let's say second router, let's say first router. So X network is how many hop away from router number 1? 17 hop, 16 hop away. So 16 hop away, till 16 hop away network will consider as unreachable. Means X network is not reachable from router number 1. Okay, but if I will talk about the link state routing protocol, so we have no limit here. Okay, we can connect more than 16 router. TTL value is 255, right? So we can connect 255 routers in OSPF. Because if we will connect more than 255 routers, what will happen? TTL value will become 0. So when TTL will become 0, update cannot pass. Okay, in link state routing protocol we have multiple types of update messages like periodic update, trigger update, partial update, and full update. First time router will send full update, and when change will occur it will send partial update, means only changed information will be there in the update, right? So these are properties of link state routing protocol. Distance vector routing protocol always send full update, but link state routing protocol send full, both full and partial. And after that, advanced distance vector routing protocol. So as I told you, example of link state routing protocol is OSPF. As I told you, advanced distance vector routing protocol is properties, it have some property of distance vector routing protocol and some properties of link state routing protocol. An example of advanced distance vector routing protocol is EIGRP. So here you can see this advanced distance vector routing protocol also maintain three table: neighbor table, topology table, and routing table. This is behavior of link state routing protocol. It also consider hop count, not to calculate metric, but it uses hop count concept. So this is behavior of distance vector routing protocol. After that, it will calculate metric on the link properties, like it will use delay, bandwidth, load on the link, these things. So again, this is behavior of link state routing protocol.
The topology table and the database table are the same?
No, both are different. Both EIGRP or advanced distance vector routing protocol maintain topology table, and link state routing protocol maintain database table.
Okay.
Okay, so example of advanced distance vector routing protocol is EIGRP. That means in EIGRP we will have neighbor table, topology table, and routing table. An example of link state routing protocol is OSPF. That means OSPF will have neighbor table, database, and routing table. Okay, but in EIGRP also we have same problem, routing by rumors. Router will not have the information of complete topology. Guys, when we will discuss EIGRP or RIP routing protocol or OSPF, you will see how routers have knowledge of entire topology, and in distance vector routing protocol how routers don't know anything about the originator, right? All routers are depend on their neighbor. So these are the properties of these three types of routing protocol. Now if it is clear to you, let me know so that I can start first routing protocol, that is RIP. RIP is an distance vector routing protocol. That means RIP is going to send a periodic update message, right? RIP is going to use hop count as a metric. RIP is going to use all the properties of distance vector routing protocol. After that, guys, RIP works at layer 7. RIP stands for routing information protocol. It is an distance vector routing protocol. It works at layer 7. So first thing is, always keep in mind, we will never enable routing protocol on router. We will enable routing protocol on the interface of routers. On router, we will run only one command, that is router RIP. Syntax is very easy to configure RIP routing protocol. Like on router number 1, I will run this command, router RIP, and then network. With the help of network command, we will enable RIP routing protocol on interface. Like on fast Ethernet 1/0, what is the IP address? 12.1.1.1. So I will run network 12.1.1.0. That's it. I will run these two commands on the router. First command will enable RIP routing protocol on the router, and this command, second command, will enable RIP routing protocol on the interface. Actually, this command is used to allocate some memory to RIP routing protocol. After running this command, router RIP, right, we have some memory on this router, so we will allocate some memory to RIP routing protocol. Please maintain your routing table there, or whatever table is required. Like if you are running router OSPF, so we will allocate some memory to OSPF to maintain routing table, database, or neighbor table. If we are running router EIGRP, that means we are allocating some memory to EIGRP to maintain their neighbor table, topology table, and routing table. If we are running router RIP, that means we are allocating some memory to RIP routing protocol. And when I will run this command, network 12.1.1.0, router will check that this network is running on this which interface. Router will came to know that this network is running on fast Ethernet 1/0. It will simply enable RIP routing protocol on fast Ethernet 1/0. When I will run network 192.168.1.0, it will check that this network is running on which interface. So router will came to know that this network is running on fast Ethernet 0/0. It will enable RIP routing protocol on fast Ethernet 0/0. Getting my point? And once RIP will enable on an interface, let's say here I have run only these two commands, router RIP and network 12.1.1.0. What router 1 will do? Router 1 will generate one update message. Router 1 will generate one update message at which layer? At which layer?
7.
At application layer, because it is an application layer protocol. So at layer 7 it will generate one update message. Then it will hand over to lower layer, like to presentation, session, transport. At transport layer, it is UDP protocol. So UDP will add UDP header, it will add source port, destination port. Then it will hand over to lower layer, network layer. Network layer will add source IP, destination IP. So RIP have two version. If I will talk about RIP version 1, so in RIP version 1, update message is sent on broadcast address. So source IP will be the IP address of exit interface. Like this update message is going to send from which interface? From fast Ethernet 1/0. So what is the IP address on fast Ethernet 1/0? 12.1.1.1. So this will become source, and destination is broadcast 255.255.255.255. After that it will hand over to layer 2, and then layer 1, and layer 1 will forward it to from fast Ethernet 1/0. When router 2 will receive it, this IP address, this source IP address 12.1.1.1 will become next hop IP address. Let me show you some more point about RIP routing protocol. It is using AD value 120. As I told you, by default AD value of a static route is 1. Like that, by default, or AD value, predefined AD value for RIP routing protocol is 120. So if one router, let's say one router is getting same network information from RIP also, and from the static routing also, router will prefer which one?
Static.
Static, because it have least AD value. Static, definitely, right? And then it uses UDP port number 520. A routing information protocol is a distance vector routing protocol which uses hop count as a metric. Okay, you understood this?
Here,
The
Prabhu,
largest
AD means what?
administrative
Okay.
distance. Are you there in yesterday class?
I joined in between, so I missed it. Might
Okay,
be.
maybe. So largest number of hop allowed for RIP is 15, which limit the size of network that RIP can support. RIP implement a split horizon, route poisoning, and hold on mechanism to prevent incorrect routing information from being propagated. RIP version 1 router broadcast update with routing table after every 30 seconds. Then we have some timers in RIP before discussing the timer, I would like to configure RIP routing protocol between router 1 and router 2. First of all, let me configure this topology. Let me access router 1. Router 2 also. Fine. On router number 1, I am going to configure IP first. Let me configure one IP on fast Ethernet 1/0. Say no shut. And IP address is 12.1.1.1 255.255.255.0. Exit interface fast Ethernet 0/0 no shut, and IP address is 192.168. let's say 1.1 255.255.255.0. On router number 2 also I am going to configure IP only. Interface fast Ethernet 1/0 no shut, and IP address is 12.1.1.2 255.255.255.0. Exit interface fast Ethernet 0/0 no shut, and here IP address is 192.168.2.1 255.255.255.0. Now see, by default, if you will check routing protocol, if you want to check routing protocol on router, you will run command show IP protocol. This command will show you the routing protocol enabled on router. So by default, there is no any routing protocol enabled on router number 1 also, and on router number 2 also. So IP protocol, there is no any routing protocol. On router number 1, I am going to run this command, router RIP. This command will enable RIP protocol here, a router RIP. And now if you will check show IP protocol, so you can see still there is no any routing protocol. Fine. So as I told you, we will enable routing protocol on interface of routers, not on the router. Until and unless we will not enable RIP routing protocol on any interface, right, you will see there is no any routing protocol running. Fine. So let me do one thing, and before enabling RIP on fast Ethernet 1/0, I am going to capture this link also. Let me capture the link. Here I have captured the link, and now I am going to enable RIP on fast Ethernet 1/0 router RIP, and then network command, network 12.1.1.0. Once I will run this command, what will happen? Router 1 will encapsulate one update message. See, are you able to see the update message, this request message? Yes. Source IP is 12.1.1.1, destination IP is broadcast. If I will open it, you can see it is, this is the actual information, routing information protocol RIP message. Source port number is 520, destination port number is 520, protocol is UDP, and inside the update message you can see there is no any information. Metric is 16, by default it is 16, and there is no any information like this is a request message only. Fine. At layer 3, source IP is 12.1.1.1, exit interface IP address, and destination is broadcast. At layer 2 also, source port is, source MAC is the MAC address of exit interface, and destination MAC is broadcast. This is RIP request message. And now on router number 1, if I will check show IP protocol, so now you can see one routing protocol is running there. Routing protocol is RIP, RIP, right? These are for filtering. In upcoming day we will discuss filtering also, then you will understand how to apply filtering. For now you can see outgoing update filter is not set for all interface, right? And incoming update also filter list for all interfaces not set. And then sending update message after 30 seconds, means after every 30 seconds it will send update message. After every 30 seconds it will send one update message. Next due update message is after 22 seconds, means after 22 seconds it is going to send next update message. Invalid after 180 seconds, means let's say one router have not received update message for 180 seconds, it will declare that route, that prefix as invalid. Hold on time is 180 seconds, it will hold any prefix for 180 seconds. Means let's say here router 1 have sent this network information 192.168.1.0 to router number 2. So router 2 will hold this information for 180 seconds, but this timer will reset after every 30 seconds because router 1 is sending a periodic update, right? So if router 2 will not receive any update message for 180 seconds, it will flush this entry, it will declare it as invalid, and it will flush the route the network information after 240 seconds. We will discuss about the timer later. Redistributing RIP, okay, leave it for now. RIP version, which version of RIP we are running? Version 1, okay. And then for which network we are performing routing? We are performing routing for 12.1.1.0, but guys, RIP version 1 support class full network. So it is saying we are performing routing for 12.0.0.0. RIP version 1 does not support classless routing. Fine. And here finally you can see distance. By default distance is 120. Okay, now I am going to enable RIP on router number 2 also, and here is the capturing. I am going to enable RIP on router number 2. Router RIP network 12.1.1.0. Now router 2 have also sent one request message. Source IP is 12.1.1.2 and destination is broadcast. Destination is broadcast. Same information are there at layer 4 in the actual update message, right? And there is information of version also, and at layer 4, layer 3, layer 2, all rest information are same. After that we are not able to see any message, right? Now on router number 2, show IP protocol. Here also we can run show IP protocol command, and we can say it is going to send next update message after 16 seconds. Now I am going to enable RIP on LAN interface also. On router number 1, I am going to enable RIP on fast Ethernet 0/0 also. So router RIP and network 192.168.1.0. And before hitting enter over here, let me show you the capturing. Once I will hit enter, what router 1 will do? Router 1 will send one update message. In this update message, if you will open this update message, you can see router 1 is sending one network information. Which network information? 192.168.1.0. Router 1 is sharing this update message, and it's saying what is the metric for this network. Metric for you is 1. Metric for you is 1. Version is 1 and rest information is same. Correct? And now if you will check routing table of router 2.
Metric 1 means the hop is 1, right?
Yes, hop is 1. Router 1 is telling to router 2 that for you, hop count is 1 for this network.
Okay.
It is sending metric, right, to router 2. That for you metric is 1. Means this network is 1 hop away from router 2. Correct?
Yes.
On router number 2, on router number 1, if you will run this command now, so IP protocol, so you can see we are performing routing now for these two network. Fine. And on router number 2, if I will check routing table, so IP route. In the routing table, I have learned one network from RIP routing protocol. R for RIP. Network is 192.168.1.0/24. AD value is 120 and metric is 1. And this network is reachable via 12.1.1.1. When I have learned this network 2 seconds ago. On which interface? On fast Ethernet 1/0. Correct? Is it clear? So IP route RIP. I can check routing table of RIP also like this. Fine. And if in the capturing you can see router 1 is sending periodic update message, right? Response message, response message. After 30 seconds it will send again one response message. Fine. But router 2 is not sending any response message. Why?
It does not have an interface
RIP is enabled on fast Ethernet 1/0. But you know, whenever let's say router 1 will send update message, In the update message, it will never include the network which is running on exit interface. Like on exit interface 12 network is running, right? So in the update message it will include only 192.168.1.0. So like this, for router 2 don't have any network to share with router number 1. Yes or no? Router 2 don't have any network to share with router number 1, because here we have not enabled RIP on 0/0 interface, so that it will share this network information. Correct? Correct. So that's why router 1 is not sending, router 2 is not sending the update message, periodically update message. Only router 1 is sending. Correct. Now what I am going to do on router number 2, also I am going to enable RIP on fast Ethernet 0/0 router RIP and say network 192.168.2.0. Now show IP protocol. Here you can see now we have enabled RIP for these two network, right? And on router number 1 also we can check routing protocol, so IP route RIP. So router 1 have received this network. Next hop is 12.1.1.2 and exit interface is fast Ethernet 1/0 and router 2 have learned this network, so IP route RIP 192.168.1.0. Fine. And now both router is sending periodic update message, and now these two LAN can communicate with each other. From router number 1, if I will ping 192.168.2.1 and say source is 192.168.1.1, see ping is working. Correct? Is it clear to all how to configure RIP routing protocol on router? It is easier than static routing configuration. Any doubt till here to anybody? Somnath?
Even without the source, it will work.
I will practice, sir. I'll ask after practicing.
Source means?
No. This 192 network is reachable via RIP now. We are pinging from R1, right?
Yes. It is reachable. Correct. Yeah. Without source also it will work. I was showing you the LAN to LAN connectivity.
Okay, so this 12 also is there in the RIP database.
Yeah, 12 is there in the RIP database. By the way, you know, so when I am pinging directly 192.168.2.1, source IP will be 12.1.1.1 and 12 is directly connected with router number 2, na?
Okay.
Okay.
So RIP
now
will always be broadcast only.
RIP version 1, we have two version.
Okay.
You know, you will understand the difference between RIP version 1 and 2. The one difference is RIP version 2 send update message on multicast address and RIP version 1 send update message on broadcast address.
Okay.
You know, first you have to understand the benefit of sending update message on multicast address over broadcast address also. Okay, so we will discuss those things. Don't worry.
Okay.
So IP RIP. So IP RIP database. We can run this command also. And so IP RIP neighbor. This command also, but as I told you, distance vector routing protocol does not maintain any neighbor table, so it is not going to maintain any neighbor table. In the database you can see 12 network is there, 12.1.1.0/24 directly connected on fast Ethernet 1/0, and after automatic means automatic summarization is enabled by default in case of RIP version 1. So it have summarized 12 network into 12.0.0.0/8. It have summarized it into class full network. Getting my point? So after auto summary, this is a network 192.168.1.0 and this network is directly connected on fast Ethernet 0/0. RIP is enabled. The auto summary of this network is same and this network is directly connected on fast Ethernet 1/0. So these information are there inside RIP database. And so RIP, is there any command like this? No. So IP RIP is there. So IP RIP database, or best command for troubleshooting is show IP protocol. In show IP protocol also you can see by default automatic summarization is in effect, means it is enabled. So that's why it is saying 12.0.0.0. Let me disable it, auto summarization. I don't want to enable automatic summarization because in my network I am using classless network. So what I can do is router rip, and I can say no auto summary. And on router number 2 also I am going to say no auto summary, router rip, and then say no auto summary. What will happen now on router number 1? See, so IP protocol, still it is summarized network, right? Classful network. Okay, and if I will, if you are thinking that after 30 seconds it will take in effect, so let me shut down and no shut this interface, and so IP protocol. And here you can see automatic summarization is not in effect. Okay, so RIP version 1 support only class full network, class full routing, not classless routing. Correct? Got it, guys? Now in the RIP we have some timer like update timer. Update timer by default 30 seconds. It will send one update message after every 30 seconds. You can see in the capturing also both router is sending update message periodically. See, lots of update messages are there. Fine. Now then invalid timer. Invalid time means after which interval of time, if router will not receive any update message, it will declare the network as invalid. Let's say router 1 have share this network information to router number 2. Have shared this network information to router number 2. Router 2 will start one timer with this network. When it will receive this network information, it will start a timer, right? By default update timer is 30 second, correct? After 30 second it will timer will decrement, timer will become 29 second, 30 second, then 29 second, then 28 second, like this. After 30 second it will receive one update message again, so timer will reset again, timer will become 0 second. For this timer will become again 30 second. Let's say it have not received any update message, right, from router number 1. After 30 second, after 30 second it have not received any update message from router number 1. So timer is going to become 31, then 32, then 33 second, then 34 second, then 35 second, like this. It will wait for this timer, it will wait for 180 second. After 180 second it is going to declare this network as invalid, this network as invalid. After 180 second, after 180 second declared as invalid. Done. And after 180 second you can see there is one more timer after 180 second, that hold on timer, right? It will hold this information for 180 second only, and it have declared this network as invalid. Now let's say router 2 is receiving one packet where destination belongs to this network, right? Timer for this network is expired. Now this network is invalid. So if router is receiving a packet where destination is, let's say, 192.168.1.1, 192.168.1.1, so what router 2 will do? Router 2 will drop the packet because now this network is invalid. But it will not flush it, it will still wait for the update message. Maybe because of congestion it is not receiving the update message, so it will wait for 240 seconds. After 240 seconds it will flush the entry, it will flush this network information from their table. Done. Like here on router number 2, on router number 2 guys, CISO IP protocol, also IP RIP database. So this network is here 192.168 dot on router number 2. So IP RIP database. 192.168.1.0 is there, right? And timer is 26 seconds, and this timer is, you can see, 5 seconds. After some time it is going to receive another update message. It is going to receive another update message. So this timer will never become 0, right? But if I will filter, let's say, update message of RIP on fast Ethernet 1/0, then what will happen? Let me configure one access control list. Access control list 101, and deny source is, let's say, 12.1.1.1. destination is source deny UDP. Deny UDP, source is 12.1.1.1, and destination is wildcard mask is 0.0.0, and destination is, let's say, NE, or we can say broadcast, and then equal to port number of RIP 500. Port number of RIP is here also, you can see 520, right? Interviewer can ask you directly, guys, what is the port number of RIP, or what is the AD value of RIP. So I am going to deny this one, 520. Hit enter. Right now it is not going to receive any update message from router number 1. So IP RIP database. In the database, now timer is 21 second, 24 second, 25 second, 27 second. Now timer is, you can see, increasing. 1 second, still it is receiving. Okay, I have not applied this access control list on interface. Interface fast Ethernet 1/0 access list. What was the access list number? Do so IP access list number was 110. So IP access group 101 direction in. So IP RIP database. 35 second. Now timer, you can see, 35 second, 36 second, 39 second, 40 second, right? Now timer is increasing because router 2 is not receiving any update message, right? So if router 2 is not receiving any update message, it should flush the entry. Because if router 2 will receive any packet for this destination, it will forward to router number 1, right? And router 1 will drop it. So IP route RIP. See, router have still installed this network in their routing table, right? This is incorrect information. This is disadvantage of RIP, right? Because now you can see I cannot ping 192.168.1.1, not ping, but still router 2 have installed this network in their routing table, right? It will flush this entry after 240 seconds. Now router 2 is not receiving any update message because we have filtered the update message of RIP on router number 2. But still entry is there in the routing table also, in the RIP database also. In the routing table also, you can see root is there. In the database also. After 180 seconds, it will declare this as invalid. Any question? Let's say my network is 192.168.1.0 is down on router number 1, but still router 2 have entry in their routing table. Because this network is down, that's why router 1 is not sending update message to router 2. So IP route RIP. See, still RIP have installed this network in their routing table. Still route is there. But here what it's saying, this network is possibly down. Now it's saying this network is possibly down. But still in the routing table, prefix is there. It have removed 192.168.1.0 or not. Here also it's saying now it is possibly down. It is waiting for flush out time. After 240 seconds, it will flush this entry in their database, in their routing table. Got it? Now let me ask you one question. Possibly down. What will happen if 192.168.1.0 network will goes down? From router number 2, I am going to remove the access control list ACL. Now you can see router 2 have flushed the entry from their routing table also, from their database also. Correct? Now I am going to remove access control list. Interface fast Ethernet 1/0. So do so run interface fast Ethernet 1/0. I'm going to remove this entry. Say no to this and no access list 101. Done. Now I have removed the access control list. Router 2 will again receive update message. So IP route RIP. So it will learn the 192 network again after 30 seconds. After 30 seconds, it will receive one update message from router number 2, right? So you can see it have learned this network again. Done. And in the database also you can see. Now here I have capturing, and this time I am going to down 192.168.1.0 network on router number 1. What will happen when I will down this network? Router 1 will generate what? Update message. In that update message, it will set metric what? 192.168.1.0. For this network, it will set metric as a infinity. Yes or no? As I told you that whenever prefix will goes down, it will set metric as a infinity. So let me show you that also. See here, this is the capturing on router number 1. I am going to run shutdown command on interface fast Ethernet 0/0, say shutdown. Where is the update message of router 1? This is update. Here is the update message of router 1. In this update message, you can see metric is fine. So it have set metric infinity, and quickly router 2 will discard the network. It will flush the network. See, this network is possibly down, and so IP route RIP. So this is another problem of distance vector routing protocol, that if network is down, it is not flushing the entry immediately. It is not flushing the entry immediately. But when it will receive update message with delay infinity, this time it will remove the network from the routing table quickly, so that it will not forward any packet to what? Router 1. This is the configuration of RIP, and we have discussed the timer. Now let me move to the next. Here, if someone need command to configure RIP routing protocol on router, so network 10.1.1. Here we are running 10 network, 20 network, and 12 network. So this is how you can enable RIP routing protocol on router. Then the version. We have two versions, RIP version 1 and RIP version 2. Guys, first difference is update address broadcast. RIP version 1 send update message on broadcast address, and RIP version 2 send update message on multicast address. Right? Now what is the benefit of sending update message on multicast address? We will discuss this, what is the difference and between these two point, our multicast over broadcast. Then as I told you, RIP version 1 is an class full routing protocol, but RIP version 1 is an classless routing protocol. Here VLSM does not support, here support VLSM, right? Does not support authentication. Here we cannot configure authentication also, but in RIP version 2 we can configure authentication also. Then we have some drawback of RIP routing protocol, and then we can start next protocol, that is RIP.
Can you show the metric infinity in the Wireshark?
Matrix infinity means matrix 16.
Oh.
Here you can see.
Okay. Usually it's 15.
16 means
15
unreachable.
16 is
Yeah, 15 till 15 it is valid.
Okay. Thank you.
Right. Now let me check. I have one lab on RIP. Okay, I will search. I have lab on RIP routing protocol. I will share that lab and you guys need to configure it. Okay.